The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. InsideAnalysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanaugh.
All right, ladies and gentlemen, welcome back once again to the future. The future is here already. So said William Gibson. It's just not evenly distributed. Your host here, Eric Kavanaugh. Oops. Hey, folks. Hopefully you can hear me now. I just heard we were muted.
I've got you.
Okay, time for Inside Analysis, folks, the only coast-to-coast radio show all about the information economy. Yours truly, Eric Kavanaugh here. We've got Yves Mulkers and Rick Sherman, two of the smartest guys I know in the business, on the call today to talk about something that is really the bread and butter of data management. We're going to talk about ETL to ELT, the good, bad, and the unpleasant. Yes, famous Clint Eastwood movie, Good, Bad, and the Ugly. No, it's not that ugly. It's just, it is unpleasant, though, when things don't go right with ETL, when you're trying to move data from one system to another. You're trying to do some analytics, for example, and you got to have all your engineers line that stuff up. A lot of data scientists say they spend 80% of their time still just hacking through data, trying to get it into a usable format. There's no such thing as perfect data. Well, machine data is almost perfect, I guess. If you understand its schema or how it operates. But most data that we're using to analyze, well, traditionally, up to 10 years ago or so, it was almost all transactional data, maybe some clickstream data, things of that nature. But today, there's all sorts of data that's being used to analyze what's happening. So ETL, for the layperson out there, refers to extract, transform, load. ELT just moves that loading process, extract, load, transform. So in the latter, you're loading all the data into the target system and then worrying about the transform. So if you think about why we had to do this, we're pulling data out of source systems like ERPs, we're pulling data out of clickstream analysis, for example, web servers, et cetera. All sorts of machine data is used these days. You pull it out of that system, you want to transform it into some format, some shape that's going to match the schema of the target system, so you can then load that sucker in there. And that's what you did. And ETL, I mean, goodness gracious, it was 14 odd years ago in the first year of my radio show, DM Radio, that I started scratching my head and wondering, wow, it seems like there's a lot of redundant effort here. I mean, performance is always key, and just getting it to actually work, getting the load to occur successfully, extracting it properly, loading it properly, et cetera. That's always an issue. There are lots of little just nitty-gritty details that can throw you off. Delimiters inside of fields. This is one. I've done this myself. I've been doing ETL in a small way for about 20 odd years now. And I've seen it happen where you have a delimiter inside the field, and then the translation engine that's actually loading the data thinks, oh, this is another field. No, it isn't. There's just a delimiter inside the field. So delimiters are typically commas or sometimes spaces, sometimes tabs, sometimes semicolons. There are lots of different things you can use for delimiters. But if you have, let's say, a comma inside a field and you're using a comma delimited format, guess what? You're going to wind up with mismatched columns, and all of a sudden everything shifts over and you've got an address in the phone number field or whatever the case may be. Well, that's not good for business. And that is how a lot of those mistakes happen. Frankly, you have these delimiters inside the fields. That's just one of many issues that you run into. Well, there are lots of big vendors that do ETL and have been doing ETL for years. Informatica, of course, was the 800-pound gorilla for years. I heard they're actually moving away from PowerCenter. I heard that just the other day, which I found remarkable because PowerCenter was their foundation, has been for a long, long time. But there are lots of other vendors that do ETL. There's a company called Ab Initio, which is the most secretive vendor in the world. They won't talk to analysts. If you go to a show and you're an analyst and you start talking to them, they're going to say, nope, walk away. They won't even tell you what they do, which, hey, fair enough. But lots of companies do that. But there is this whole new wave of companies coming out that do things in a remarkably different way. Well, guess what? That's good for performance, but it's not only about performance. I often thought, and still think this today, that observability, a strategic view of what is in your systems, a strategic view of which data is going where is really important. That can be done largely by metadata. the metadata of which systems we're pulling, which fields, which columns, et cetera. That's very useful stuff. But if you don't have that, well, that's what most companies today even still deal with, is they have hundreds, if not thousands, or even tens of thousands of batch scripts, ETL batches, they call them batch windows. And it was usually done overnight. So in the daytime, the business does what it does. And at night, all the engineers would set up scripts to run to grab data from this system, put it in that system, grab data from that system, put it in this system. That happened all night long. Those are the batch windows. Well, over time, there's no more time. There are no more windows overnight to get the data in there. And then, of course, now we have 24-hour businesses. So that kind of approach doesn't really work. Well, there are lots of other things that have been done too. Data virtualization has been around for at least 15 years. There's some really new and interesting takes on that and how that stuff all works. There's of course just strategic caching of data, for example. So there are a lot of clever things you can do, point-to-point movement of data. But the topic for the show today is really to talk about how we went from ETL to ELT, and then what are some of the newer interesting things going on. And I'll say one more thing before bringing in our buddy Yves, and then we'll bring in Rick Sherman from Athena IT Solutions. Yves is 7W Data. If you don't know it, look these guys up. Wonderful brand. Yeah, so getting it in there, that's important. The visibility is really important. Understanding what it all costs, that's really important too. You know, TCO, we talk about total cost of ownership. How much does it cost to have all your engineers pulling their hair out day in and day out, only to quit and go away, right? You have stored procedures that are used. There are all kinds of different things that can be done. But the key is the more visibility you have into which data sets are going where, the better off you're going to be, because A, you can limit the amount of extraction and loading necessary. That's pretty important. But B, you can also better understand, what are you paying for? What is the value of all this? Are we using ETL scripts to load data into tables that aren't even being used anymore? Short answer is, in most organizations, yes. You know, imagine like the way you leave your TV on at night and your other things, and the electric bill goes slightly up. Imagine that times 10,000. And that's kind of what's happening at some large organizations. So with that very long intro, I'll bring in Yves Mulkers of 7W Data. Yves, you've been a practitioner for years, and now, of course, you're an analyst in the space and a media guy. I'll bring in Yves first, Mulkers. There he is. So tell us a bit about yourself and what you think about the evolution of ETL to ELT and beyond.
Yeah, Eric, thanks for having me. ETL, I think the title is very appealing. The good, the bad, and the unpleasant, having done about more than 20 years of data integration and still doing a lot of that stuff hands-on. I think you summarized it all pretty well on delimiters, on types of fields, whatever, that causes those data pipelines to break, and the windows getting shorter and the volumes of data getting even bigger, and trying to fix that in one night window, or even preferring to have that in a real-time capability to do a real-time analysis. That puts it into perspective, where we need to handle those big volumes and data pipelines in a different way. First part, which is very important, is all the time that data integration. Back in the days, well, still in these days at the data warehouse, we're talking about the conform dimensions and master data management aspects, where you try to align the definition of a customer onto that certain customer, so you can identify it as one and identically the same customer, to map all your sales, your orders, and everything on that single customer. So that was the idea of having an integration layer. But having the big volumes and the disparate types of data what we have, we moved into the ELT, the extracting and loading part. So first standardize on the data type, so it becomes easier to organize and group your data from various systems. Typically, back in the days, it was an Oracle database, for example, where you had to get all your data for the operational systems. But in these days, you combine it, like you said, with clickstreams, analytics from a Google platform. You pull in some APIs where you have a JSON type of data type. And that also makes it more difficult for non-technical users to combine all of that data. And I think that's where we are heading to with ELT, to have that standardized and have that in a standardized way, to it's easier to consume all the data in a single data type, and provide that to business users. And then the next steps is where you have all that massaging and standardizing of your data. It becomes easier to combine that with different sources and move you faster into combining various data. And typically with the cloud and where you have compute on demand and moving more into in-memory technologies, that helps all in massaging those high volumes in such a shorter amount of time.
Mm-hmm. Yeah, you brought up a number of really interesting and important points here. One, with cloud as the target, and of course we have change data capture. We shouldn't forget about old-fashioned CDC, which is a very useful tool. You have to get it just right. Obviously, you have to set these systems up just right to work effectively. But change data capture, I mean, that's been around for 40 odd years. It was born of the original constraints. So they had to be very careful about how much code they pushed and what that code did, because back then it was very, very expensive. And then of course, code load over the years. But now with cloud being the target, I think it makes a lot of sense. You just kind of hinted at that because you have so much compute up in the cloud. So if you were extracting and then transforming on your servers in your data center somewhere, let's say that takes 10 minutes to do. If you extract and load into the cloud, similar kind of solution, then do that transform, it's probably going to take about 2 minutes. I mean, depending. But the point is you save money. And, you know, this is this real opportunity cost when things don't work very efficiently. You know, people kind of get acclimated to the speed of their business and the speed of their job and what they do. I mean, I think of the old days when you would hit enter on Adobe Photoshop to run some big filter, and then you go get a bagel and come back and it's finishing up. And you see, did it work or did it not work? I mean, people did that with ETL, right? You just, all right, let's set it up to go. And you forgot some setting and you come back 2 hours later and like, you got an error message. That is very, very unpleasant stuff. And it erodes morale. And it results in the business not getting what it wants. And so I think the key is always the performance. Did it get done quickly enough? But did we get everything that we needed in there? Right? These are the questions that get asked. And I think what's happening now is that the old guard, the old way of doing it with all these ETL batch windows, they just ran into a brick wall and they had to do something different. Is that your take, Yves?
Yeah, that's the part where you say too many times that the nightly loads just broke, and due to some simple changes on unexpected things into the source data. And that's why the ELT is kind of solution to that. You just pull it in and then you fix these kind of issues. And those are mostly technical issues, metadata related type of things, data types, separators. Well, how many times that the revenue just increased a tenfold overnight due to some decimal separators that went in the wrong way, or just a currency conversion that caused that. And that helps as well, where you pull in the data as it is from the source, that allows you to better analyze how it looks like and then see where it really went wrong. Before you did the ETL, you did extract and then the transformation. So you had a kind of logic before your data landed into what we call right now the data lake, before we called it the staging area, before it went into the data warehouse. And I think that has some big advantages on in doing it in that way, still, because you don't know what you're going to do with your data. So if you have that already available, you can look into that and you say, okay, we can combine it for algorithms for the AI team, or we can use that for regularity reporting, and then use it in a different way, because the modeling on that data is a bit different, but it serves to, well, in the end, the same kind of outcome, but people work with the data in a different way. So for me, it's more a typical way of doing that right now, of just getting that into one zone and heading for the extract, load, and transform.
Yeah, you know, I'm reminding myself of my ancient history. And right out of college, I stumbled into a job at a small town newspaper as a reporter, and then I took over as editor. Actually, when the publisher had a stroke, God bless him, that's when I became the editor suddenly one day. But we had linotype machines in the back. All right, so this is 1990 and 1991, and so what we had the very early Macs that we used for layout. So it was, it might have been Quark Express, one of the earlier versions of Quark, and we'd lay the paper out. and you would actually print it up. You had a big camera to do halftones, so you can get pictures and things of that nature, because you need halftones to print that stuff on paper. But the headlines, we used to use a linotype machine, and the material for this was pretty expensive, and small town newspapers don't make a lot of money. So what you'd have to do to write the headline is you would have to type out the entire headline, and you better get every letter correct, because you can't see what you're typing. There was no screen to show you what you were typing. That reminds me of the old ETL, right? You're like, all right, well, just set up this extract, and then we'll just transform it in the middle and load it over there and hope to God it works. And if it doesn't, you're like, oh, back to the drawing board. But as you're describing now, by doing the ELT, and if you do it right, obviously, then the person on the other end can see all the different data components. You don't have to just scrape out all these other fields. You can kind of see what's there and then go, oh, you know what? I did want this field. I did want that field. So it gives more visibility to the data practitioner, the engineer, to use the ELT format. Is that about right, Yves?
Yeah, exactly. And what I see is why is it's moving to doing the transformation after the loading is because we have the in-memory technology, which is so much more performant than it was before. So you can do the transformation, mess it up, and then quickly redo it. Before we had to copy it 3, 4 times, 5 times before you get into the end. And that copying of the data, that took an awful lot of time. Now with in-memory technologies, it's kind of a view on top of a view on top of a view. Data virtualization tools helps you a lot in putting that up in a logical way, the combination of all your various layers on how you get to the final data model, let's call it like that. And that's where I think, thanks to very performant systems and in-memory technologies that support that speed and huge crunching of data, that's why we're moving into ELT now.
Yeah, that's what a good point. It's so interesting. These technological innovations, these hardware innovations change everything. I remember my eponymous partner, Dr. Robin Blort, one time he built a little pyramid that showed where all innovation comes from. And it always starts at the hardware layer, and then it moves up, maybe probably to firmware, and then software and the apps and et cetera. But if you have an app that is able to leverage that in-memory capability, like you're saying, again, it saves tremendous amounts of time, but it also gives so much more agility and visibility to the person using the tool, like using the technology. Because when you can see it and shape it, it's like trying to shape clay in the dark, for example. Yeah, you can do it. If you're a professional, you can do it very well. But if you're not a professional, shaping clay in the dark is going to be pretty error prone, and you're going to wind up being pretty unhappy because there are unpleasant results. So we'll pick this up after the break, folks. We're talking to Yves Mulkers of 7W Data and Rick Sherman of Athena IT Solutions. Don't touch that dial. You're listening to Inside Analysis. We'll be right back.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
Take us to the future.
All right, folks, take us to the future indeed, where all the data is already loaded and analyzed. That's what we're talking about, folks. All the nitty gritty, rough stuff, like moving it all around. That's what the engineers do. A lot of them are unhappy when things don't work properly. The key is that you want to be able to see it and know. And we're getting a lot better at that sort of thing, a lot better at being able to identify where something broke, why it broke, be able to remediate, fix. Even if you have a very sophisticated system, have some algorithms in there, machine learning, that are constantly scanning and watching for this stuff, looking for this stuff, sensing when there's a problem. And then over time, they learn to fix that problem. They can do what they call self-healing. We're kind of getting in that direction, which is exciting. But let's bring in one of the most seasoned veterans I know in the field. He's always working on something interesting. Rick Sherman of Athena IT Solutions. And Rick, I'll throw this question from an attendee over to you. One for our live studio audience. If you're listening riding down the road, you can join us as we record these shows. Just send an email to info@insideanalysis.com or hop online to our website, and you will find out how. But someone's saying, hey, it's interesting that the T happens last. Are you suggesting that the data is staged before loading into production, or that the transformation happens inside the production environments? Can you tackle that for us, Rick, and tell us your thoughts?
Sure. And actually, first off, I want to say that the idea is to move data into a staging area, ingestion area, data lake, whatever you want to call it, getting it off the source systems to begin with. And then I think the ELT, I think there's more than one T, And I think that's what people have to realize, right? So it isn't like if the questioner is thinking production is what they finally see in the dashboard, there's a lot of T's that are happening before that. So bringing the data in a staging area or lake, then do an integration where you're doing, if it's structured data, maybe you're doing master data management, conforming data, making them cleaning things. Your example about commas and delimiters, I mean, little trivial things like that to clean up the data, put it in a place that it's digestible and understandable by people. Tracking history. There's a lot of different sort of hygiene, mundane stuff that happens to data. The longer you have the data, the more that you want to do it. Then of course, if it's structured or semi-structured, there's other processes that you do in order to curate that data or understand what that data is. Then it gets into some kind of distribution where, okay, is it going to go to BI? Is it going to go to other applications? Is it going to go to other processes, data processes that are going to ingest it and run it in a business process or something else? And then finally, it's the last mile. If it's going to a person that's on a dashboard, there's going to be further transformations either happening before or during the analyzing data on the dashboard or spreadsheet or whatever they're going to use. So it's a continuum, and it isn't just a one-time T. There's multiple T's. I think one of the issues that we had before is people try to do everything all at once.
Right.
And when you try to do everything all at once, you usually fail. Right?
Mhm.
So you're talking about observability. If you do have it in this iterative, stepwise approach, then you can monitor or check observations, what's happening to the data as it's moving along. There's nothing that says not only machine learning, but even if you're not using machine learning on it, if you're using analytics and dashboards against the data as you're transforming it, why shouldn't you do it as the data progresses, as well as when your business person finally looks at it at a dashboard? You can use the same technologies to look at it along the way. So you do take the data off, and then you can do lots of things to it. That Yves mentioned earlier about memory. Memory has been the biggest boom to integration and transformations that's been out there. The ability to be able to take data from disparate sources and do all sorts of these transformations and integrations in memory has really sped up processing, but also given us much more ability to do things useful to the business, as opposed to like them getting into spreadsheets and just trying to do the best they can. I mean, there's a lot more stuff they can do. The thing I also did want to mention, Eric, on this is a little bit different, but is the fact, going along with a sort of trying to do everything all at once or one size fits all, is we have a lot more integration options nowadays. We have pipelines, data prep, ETL, ELT, APIs, application integration, a lot of different ways to manage, to integrate data. A lot of it overlapping, and too many times, ironically, we have integration silos in companies. I mean, we have the application group moving data, integrating it one way. We have the person doing data lake or data lake house doing it another way, the traditional data warehouse doing it another way. And I don't mean just using different tools, but transform. That'd be the easiest thing to deal with if they're just using different tools. It's the fact that they're not doing the same kind of processes and they come up with different numbers, or different data isn't as consistent between one set of applications and the other applications, and the data starts diverging. They start off in the source systems sort of integrated together, and then they ended up with more silos than they started with. And that isn't necessarily tool issue, it's just understanding and trying to orchestrate the problem. And I think too many times people gravitate toward one technology and one approach as being the end all be all. I mean, relational databases aren't the end all be all, but there's different types of databases for different types of storage and applications, and same idea with the integration side. You need to be able to look at it.
You brought up a really good point here too about organizational structures and how important it is to understand where that will impact your data strategy and your pipelines and so forth. And when we watch data lakes rise in prominence over the last, let's say, 7 to 9 years or so, first with the Hadoop movement, now even beyond Hadoop, we're still talking about lake houses and different fancy terms to describe things. But what really struck me more than anything was, from my experience, if you had a data lake, those folks had nothing to do with the data warehouse. It was
Right.
a completely separate group, completely separate objectives, a lot of times different data sets, right? I mean, you weren't using all the data that the warehouse was using. You're typically using machine data or other types of things to find your little gold nuggets. But the point is completely separate, not talking to each other, not orchestrating anything together, just 100% separate groups, which sounds crazy, but I do understand how it happens, because you have a large organization with lots of people. You need to get a couple folks to interact, and they probably don't even want to do that because it's going to slow them down and they're not going to hit their targets. They're not going to get their work done. But what do you think about all that? And how do we solve that?
Yeah, and I think historically that's been an issue just straight with application integration people, the people that are integrating the data between the ERP systems, CRM systems, moving data in and out of Salesforce or whatever apps that are out there. And the data warehouse folks, traditionally, they were often operating on the same data and never communicating with each other.
Right.
And the data moved back and forth between those. And then, as you said, the data lakes sprung up and they didn't work with the data warehouse team, or vice versa. So that's one of the areas where organizationally you got to really look at data, not just the separate silos of the data and integration data. You got to really look at how do we actually, I mean, that's why they have CDOs, but why are we actually handling the data, and how do we manage the data overall, not just in our little silos. That's important. And that's been a problem with a lot of wasted efforts and a lot of knowledge. I mean, a lot of the application folks, their knowledge of the databases, of the processes, the people working on data lakes, their knowledge of structured or unstructured data and machine learning, the data warehouse folks who have the expertise with master data management, handling historical data, and doing a lot of the mundane structured integration work. All those sets of expertise should be a pool for the company, not just silos unto themselves. And
yeah, right.
In order to really integrate data, you have to have all those aspects together. But the application folks don't know how to do the data, the historical data and the data cleansing. So a lot of stuff gets wasted by the side. A lot of overlap with it. There's more platforms that are more conducive to being shared across those different integration personas and the different folks. And I think that's what we needed to move towards, to be able to share that. There's certainly more frameworks for active metadata and other kind of capabilities being embedded in some of these little more all-encompassing systems that different groups can share. And I think that's what we're gonna have to go to. But organizationally, I think people, forgetting the tool sets, people need to look at data and data integration holistically, and not just individual pieces. I mean, resources are tough, right? It's tough to get people, tough to get skilled people, right?
That's right.
You don't have the ability to have to stock to build up teams in each of those areas. Now you really need a common team that you can leverage your skills in the different applications, as opposed to building out separate teams.
Yeah, I'm glad you brought that up, because it is part of the abstract. We wanted to talk about that today. Good help is hard to find, especially in these times after the great resignation following the pandemic, et cetera. I actually wonder, constraints are always interesting, because constraint-based design is like a pragmatist's dream, right? Like, you have to understand your constraints and work around them. And even though the constraints have changed dramatically, there are new constraints. And there's one in particular that I'm thinking of, and I wonder, I'll get your take on it, maybe bring Yves in to discuss this. Regulations like GDPR and out of California, CCPA, and they've got some others they were trying to pass in New York and other places as well. Obviously, there's a lot more interest in privacy these days, which is good and ironic, I suppose, at the same time. Do you think that helps the cause to limit copies of data? Because we know that when you copy data, you just multiplied your governance problem by 2, if not 3 or 4 or 5 or 10. You got 10 copies floating around. That's 10x the challenge of data governance, right? So if you can get it down to 1 copy and kind of master that concurrency challenge to have multiple people hitting the data set, but have it only be 1 data set, it seems to me that kind of helps the challenge here. But what are your thoughts on that, Ray?
Well, 2 things on this. One is certainly it would help from that context, but I think the bigger help is the fact that it's providing more visibility into the data, and that you really do to manage and care and feed it. And it isn't, you mentioned cowboys before, it isn't the Wild West. It does have to be managed. On the other hand, with cloud resources and the ability to do things quickly. I mean, it used to be spreadsheets. Now we have a lot more capability than just spreadsheets to make copies of data and spread them around, and even complying to the regulations. Companies and people do lots of things that don't really comply with the regulations out there, right? Given the ability to do it and try to get their job done. I don't mean that they're trying to skirt around, but they do it without even thinking about it. So I think it's more the case. I think it's
thinking badges.
I think it's more the case that it's bringing visibility to the importance of data and managing data. You know, and anything like that, I think helps, because I think it's important to get that thought process in. I mean, that's really how you get treating data from an enterprise perspective, either enterprise perspective, right, with your partners and suppliers, etc. It isn't just your data anymore. It's a lot of people that you're interacting with. So I think it does help. We'll see if it keeps people from being cowboys.
There you go. Watch out for those. The Lone Ranger, right? We know what the Lone Ranger coder is doing his or her own thing, right? And Yves, I'll throw this one over to you. Again, I'm looking for ways to be able to strategically manage the operation, right? And for lots of large organizations, that's very hard to do because you have lots and lots of moving parts. But real quick, 1 minute before our next break, go.
Well, I think just trying to avoid the copies and looking from a holistic perspective on what you can do with the data, and trying to minimize the repetition of things you do with your data, like the AI team is prepping and cleansing the data, the BI team is doing that, and the regulatory reporting team is doing exactly that same kind of thing. I think condensing those type of tasks into one team, that helps already a lot of optimizing your resources, and as well the speed on how you can deliver and create business value based upon your data. So getting into those abstractions, I think that's a good approach, and thinking not only about the technology. I saw some discussions on what do you use for the T. Do you use SQL? Do you use Spark? Whatever. But it's not about the tooling. It's about the logical approach of what you do with your data and how you move that to insights.
Yeah, and being able to your point, to visualize that, and then being able to explain that to the business. You know, the more explainable something is, the better off it's going to be sticking around in some organization. If you can't explain why you're doing something, then you're probably not supposed to be doing it, or maybe it doesn't have as much value as you thought. But these are all important aspects, because it's a big picture, folks. Don't touch that dial. We'll be right back. You are listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to 2 veterans of the industry, Yves Mulkers and Richard Sherman, or Rick Sherman as I call him, of Athena IT Solutions. We're talking about ETL to ELT. Of course, ELT is great for the cloud. And I think to myself, I really wonder about this. I know the devil's always in the details, but maybe Yves, I'll throw this to you, and then Rick, you can comment on it. We moved so much data in the past. We moved data that we had already moved. We moved data we had already moved countless times. Obviously, change data capture is one way to deal with that. And for those who aren't familiar with the concept, with change data capture, you only move data that is changed from the source system to the target system. So when I bought a new car, for example, that would be an event. So like, okay, well, let's just move this new event. We're not copying the whole file over every time. We're just copying over what changed. Now, to be able to do that, obviously, you have to have pretty sophisticated technology that knows what changed in your source systems and knows what you've mapped up into the target environment, like the data warehouse or whatever, the cloud data warehouse. But it's certainly for companies that have like customer data and have lots of divisions that need to access that customer data. I think sometimes you do wind up populating that out to separate copies, and that's a dangerous situation. You always want to have one command and control center that oversees what's going around, what's moving around your operation. And to me, a lot of data doesn't change. So I'll throw it over to Yves. Should CDC be a much bigger part of the matrix here of moving data around and being strategic and being efficient, or is it just too complicated?
Complicated, not really. I mean, it's a setup. The technology and tools are out there to help you just manage that in a certain way. But I think it depends on the use case, on how you will use your data. With change data capture, like you say, you have every transaction, what happens in your source system. So you see if somebody changed their policy about 5 times, changed their address about 10 times over the last 2 years. Those are maybe insights that can be helpful for your business back in the days, because we didn't have the technology, the capabilities just to keep track of all these intermediate transactions during the day. We were just already happy with having that snapshot by the end of the day, the status of how many products a customer bought. But now you want to see, for example, if they visit your website, which page they looked at, where did they click. So you want to have every little gritty little detail to see what is their behavior, because based on that behavior, you can build models and you can do so much more with that. And change data capture, I think, definitely looking at the use case, but how I would set up these modern data platforms is using change data capture and putting all those transformations and transactions into the data lake, and then work out from there what you need in the end. So definitely you don't miss anything out from what is happening in your application environment.
Yeah, I'll throw this over to Rick to comment on. What do you think about that? And what do you think about some of the newer, really interesting technologies like dynamic data pipelines, right? Where you use, you don't use imperative programming, you use declarative programming to say, okay, I want this data over here by this time, go get them. Is that something that you see happening out there, Rick?
Okay, so I mean, first talk about the CDC side. So certainly, I think one of the things we go back to, you talking about the people in the data lake, we're talking to the data warehouse folks and the application folks. I think what we really need to look at is distributing data, and whether it's a lake, warehouse, combo, but looking at, we take the data, we do change data capture, we have the history of, the products they bought, history of the websites they visited. I mean, that happens all the time, or have that data and have it the ability to then distribute it or ingest it to other applications, other business processes, machine learning algorithms, or whatever. But the idea is everybody doesn't go out and get their next copy of it. They end up pooling it. It's a distribution hub, whether that's a lake, data warehouse, combo, whatever. But looking at it, if it's a mesh, whatever you want to do, but the go-to isn't by default to get your own copy. The idea is if it's been integrated, if it's put into the lake, if it's staged, if any kind of transformations happen to it, start off with there. Don't start off from going back to the pipe again, because you're just reinventing your own wheel. As far as sort of the dynamic transformation and ingestions, some of that I think is plays out better with it's starting to evolve with established cloud apps and models, as opposed to the legacy applications that are out there, especially ones that either were homegrown or had lots of different customization done to them. I mean, that even happens, even though it's a newer platform and a lot more open Salesforce. The issue is, 90% of the columns are customized, attributes are customized, right?
Interesting.
And so how do you dynamically set up ingesting account data when accounts are defined differently between everybody that's ever used this product, right?
Wow.
So I think there's some good opportunity in that area, but I think there's a lot more variability in the underlying data and the underlying data models. I think as soon as the technology gets into being able to absorb variations in the data models, or have you learn what those models are and what those relationships are, then I think that then that moves ahead a lot farther. But there is a lot of different variability in those models and the relationships between the entities and the objects within them.
Yeah.
So,
I'll throw another question. We've got a few minutes left here before we go to the podcast bonus segment. Yves, when I think about the cloud and when I think about distributed database, now you've got all these major cloud vendors rolling out their distributed databases. You've got some really interesting vendors in that space, CockroachDB, for example. Of course, Amazon's been working on things, Google, et cetera. It's a very different model to have a distributed database, obviously, than to have a static instance of a database on a server somewhere. But we are getting very good at being able to handle distributed architectures. And so is the future of, let's say, customer data, is the ideal scenario to have your customer data in one of these dynamic distributed cloud environments, database environments, and then have all the different systems that want it, just ping it and get access to it. Now you got one place that you're storing your data. And it's resilient, it's durable, it's high speed, it grants access, et cetera. Is that the vision of the future, or is that still far off? What do you think?
Yeah, for me, the future definitely is distributed, depending on the volumes of data, what you have, depending on privacy regulations. Sometimes you have data that can get out of an American data center and move to Europe and vice versa. So those are the things that we definitely are looking into, distributed systems, what can have their benefits out of that. I know of a great example in Germany where the research centers, they had a difficult time of moving the data around. So they kind of kept the data where it was created. And once they needed it, they did the compute at the edge and then moved the insights centrally. And that's how they managed it. So it's a kind of hybrid architecture, what we're looking into, and you're not always able to centralize that data. So definitely distributed systems are the way to go for the future. And if you look into, you talked about the cloud, Eric, if you look into cloud and on-prem, that's still more and more. We had a few years ago that everybody was moving to the cloud, still a big move into the cloud. But more and more companies are rethinking their architecture and going back to on-prem. And you get these vendors that now offer their databases which can run on-prem and in the cloud, so the hybrid systems, and you can switch in between. So therefore, yeah, definitely distributed systems is the way to go.
Yeah, that's a very interesting point. We got a great comment from an attendee right here. CDC probably won't be the future because it requires something like a DBMS log in a system that is not ACID, that's ACID compliance with respect to database. It is not clear how to implement CDC without the even worse performance of doing a diff between old and new, which would be not viable. I mean, this gets down to issues of what systems can handle, what organizations can handle, right? There may be a vision, something looks good on paper, but when you roll that out in the real world, it's just a disaster. And that's kind of what we've seen historically with the sort of big mammoth capital expense projects is you spend a lot of time and effort building it, doesn't quite turn out the way you wanted it to be, doesn't do what you wanted it to do. I do think that distributed networks and distributed databases are going to be the future for all kinds of reasons. And it's great that we have such good competition now in the cloud between Oracle, Amazon, and now Microsoft, all just, kind of beating up on each other. And I think that does tend to hammer out standards a little bit. You look at, of course, HTTP as a standard. A lot of companies are now matching the S3 protocol for its API. So it's a sort of de facto standard that's sort of mapping out over the industry. And that is always good news. The more you can standardize within reason, the better you're going to be, because then you can do interoperability. Then it's easier to onboard this stuff and do more fun stuff with it. But look these guys up online. Yves Mulkers of 7W Data and Rick Sherman of Athena IT Solutions. Podcast bonus is next. Okay, folks, time for the podcast bonus segment here on Inside Analysis, talking to Yves Mulkers of 7W Data and Rick Sherman of Athena IT Solutions. And in the break, we were just discussing going back in time, or is it going back in time? Things like reverse ETL, things like DBT, very interesting technologies out there. But Rick, I'll throw it over to you first. Information architecture, you're even hearing now analytic architecture is really important. And you've been out there espousing these values to the business for decades now. And so you know that you have to be able to tell a story in a fairly clear and succinct way to help someone understand what are the implications of decisions we take here, which technologies we choose to go with. And the tech should never come first, right? You always want to understand what you're trying to do for your business using data, and let that sort of drive the conversation down the road at some point to technologies. And you always do want to try to use what you already have, right? If you have something, you want to use it, maybe not coding, because some people are trying to move away from coding. But Rick, what do you think about the importance of an analytics architecture, and how do all these different components fit into that, and maybe touch on reverse ETL too?
Okay, that's great. Well, the title of my course at Northeastern is Designing Analytics Data Architecture. So of course I'm into it.
There you go.
Been doing it for a while. So, and it does flow with the idea of data is transformed, staged and then transformed iteratively or incrementally based on its uses. It isn't one size fits all. And there are the whole idea of sort of one version of truth was always simplistic, right? Because you look at something like profit, there's a different definition, legitimate definition for different parts of the business, right? Or different points in time.
Right.
Well, let's going back to reverse ETLs. We sort of talked off break. I was kind of shocked to see sort of this term reverse engineer come up in the last
reverse
year.
ETL. Yeah.
What did I say? Reverse engineering?
Yeah.
Reverse ETL come up because it's like, first off, the whole idea of taking data from a warehouse and moving it to an app, we've been doing that for years. I mean, that's great, right? You're distributing the data to its use, but reverse ETL, it's like, why was that invented? I mean, why are you having a different tool do that? Why shouldn't it be your integration tool, integration process doing it? As an aside, some of that has to do with some of the cloud ETL tools made an assumption is that their only target was a cloud warehouse.
Interesting.
Which is very short-sighted. Most of them don't, but there are a few that do. I think that might have been what caused it. But the other reverse part of it is there is no reverse. You're further transforming the data for its use case, right? This reverse seems to imply like you're going backwards, and you're not, right? So having yet another tool to do another little segment seems silly. Not that the tools aren't good, but having a tool to load a cloud warehouse and then a tool to take the data out of the cloud warehouse and move it to another app, that seems disjoint to me. That seems to be too efficient in that space. So, but cloud architecture is important. Looking at the different aspects of what kind of integration cases that you do have. You're doing streaming, you're doing batch. What are you doing? Where do you need the data? Is it event driven? And then how does the data transform? Is it transformed? Are you using machine learning on the side? Where should the integration happen or transformations when you're using dashboard tools, Looker, Tableau, et cetera, out there? I mean, a lot of things happening with data, and still there's a thing I heard called spreadsheets that's still out there that a lot of stuff is going on too.
Spreadsheets are still everywhere. Yves, I'll throw this over to you to comment on analytic architectures. And then, of course, all the cloud offerings are going to have their own services for loading data, for extracting data, for doing whatever. So at what point do you use what they provide versus buy some best of breed technology to get it done the way you want? And of course, all these tools that you're buying, increasingly, you're seeing tools that run in the cloud environments, right? You just build your technology using the services provided by AWS. That's kind of an interesting trend too. But what do you think about best of breed versus what's already built in, and how do you know if it's good enough, Yves?
Know if it's good enough. It depends on what you need, and getting that clear. And I think there is the reason to exist for architecture, where you first try to define and give a kind of picture of what you're trying to build, and especially specify the functions and capabilities of that system and what that will bring to the business. You get a point of discussion of, hey, this is what we're going to build. Is it really what you want? And does it really solve your problems? When you say the best of breed and what has been already built, my advice is definitely to look what is already out on the market, and don't try to reinvent the wheel, because there is so much knowledge that has been already built into these systems that helps you already take a very big leap forward before you even start to think on what are the best practices I need to take, what are the standards that I will implement. And just these tools can help you out in moving faster forward as such, but definitely as a business understanding of what you're trying to achieve, and not selecting because it looks like a really great and cool tool. It's this discussion we're having amongst architects as well. You have the marketing fluff where everything is possible and it solves all your problems overnight. But you really need to look into if you really need that tool for the type of problem what you're trying to solve, and bear in mind as well of it needs to be flexible, and it needs to move along with your business and grow and scale as you move forward. So
That's
maybe
right.
you select right now make a selection for a database right now, but in the future you need to be able to pull out that database and have it replaced by another one. And I think in that respect, reverse ETL comes into place as well. Something has been built by somebody who's no longer with the company, and you have a hard time of understanding what all the data movements are. So having reverse ETL in place, you can get an understanding of the transformations, what you're doing, because you never documented your processes around that.
That's right.
So yeah, architecture in that respect has a real place, and needs to get more attention of building sustainable solutions.
Well, you heard it here first, folks. If you're looking for a job, maybe you're in the service industry, you're looking to do something different, go into data. It's never going away. We're always going to have data. We're always going to need data engineers. Look up my friends online, Yves Mulkers of 7W Data, Rick Sherman of Athena IT Solutions. Ask them any question you want, folks. They're the experts. And we'll talk to you next time. You've been listening to Inside Analysis.